Hi guys, my name is Munzagera. I'm here to present you the program or the project of the student attendance system. And I've been doing this project because of the following reasons. One, reduce the paperwork in the teaching and learning system, missing of the attendance marks and attendance papers, and a known number of students and ghost numbers. Problems be solved misallocation of attendance marks, so our attendance marks will be allocated appropriately, missing attendances, and a known number of students. These are the reasons why. The reasons why I choose this one is because that those papers should be eradicated, and they will be eradicated how someone will be assessing the attendance of the students by online, by internet, by using gadgets. And the methodology I chose is prototyping because users involved into the project development, and it is easier if there is no exact estimate of the number of resources available, and good project productivity. Phases: planning, initiation, analysis, design and implementation, maintenance. The Gantt chart of the student attendance system. This one is the Gantt chart, which shows the number of the tasks and the subtasks and time it will take for them, even when they will begin and when they end. For example, planning, which has 5 subtasks, which will take almost those days. So we go to the planning phase 1. The planning phase has, as I said, has 5 phases. One is assessing the purpose of the project, assessing the need of the project, identifying the cost of the project, and very many others. The cost, it is that because it was estimated because for prototyping, you don't know the number of resources available, so you have to not be clear on the cost and cost to be incurred. So the requirement, which is the second phase, requirement gathering. Third, 4 activities, which had also sub-activities, and it took those all days. User requirements, we begin with what a user want to see. For example, he want to see the system that is easy to use, fast and secure, private, and very many others. Then business requirements, we have the response time, the attendance system, what the business needs from the system, and the function requirements. This is what the system will do. And for example, it will allow the lecturers to log in, verify the have logged in, and very many others. So after this, the functional requirements, we go to non-functional requirements, where non-functional requirements should be available are those that the system, how will it behave? So it will behave by being available 24 hours, it will be quick, it will detect errors, and very many others. The system requirements, both software and hardware, are command. And for example, NetBeans as a software requirement, and JTK fingerprint system also as the software, and fingerprint scanner, PC camera, and motion sensors as hardware requirements. Then we go to the context diagram. This shows how the different actors will interact with the system. For example, the student will provide the lecturer will take attendance, and the system will provide the report, and other actors according to their categories. Then we go to the use case for student actor, where student, those are the activities the student will do in the system. For example, registering, logging in, providing password, fingerprints, provide facial recognition, attend, respond, attendance, view, and log out. Then we go to the use case of the lecturer, who is going to register, login, provide password, take attendance, view, log out. Then we go to the general use case, which has all on my right there. On your right, they have secondary actors, and on the left, they are primary actors. So the secondary actors are mostly especially the systems, that is your system will interact with, and the primary actors are the users. So we go to the work breakdown of the student attendance system. That is the planning, this activity and its subtasks, the action it will take, and very many others. So for example, the planning, which we have already seen, has five of the subtasks, and they will take almost, roughly, if you add those days, it will take like 2 weeks, 14 days. So we go to the data flow diagram, how data will be shared among different data stores and actors and processes. For example, a student here will register, and after registering, it will be stored in the student attendance system, which will provide the same data to the student database, which will provide the same data when he or she is logging in for verification. So we go to use case inactive. For example, the use case, this one, it is called the registering, which is the primary capital lecturer who will register, and it will go under those typical steps, and it's called typical coursework overflow. And you go to the conclusion. Those are other use cases for reference. Then we go to the entity relationship table, where every entry, such as the student, has attributes such as first name and last name, and each attribute has data types such as character and integers and very many other data types. Any consequences, for example, any consequences here in the student registration number, then we have the primary key, which means the primary key, the student can, the student reg number will uniquely identify the students, so they will not find very many students having the same registration number. So if one enters the registration number in the database, it will provide all the fields for one student, not very many students. So that is the entity relationship table. Then the entity relationship diagram. This is how the relationship, how if different actors, entities relate. For example, the lecturer records 0 over many students, and one or very many students are recorded by a lecturer. The student attends one or very many courses, and a course is attended by 0 over many students. A lecturer instructs one and very many courses, and one course is either instructed by one lecturer or very many lecturers. So we go to the system architecture, where the system, how the data, how the hardware or the users will interact with the system. They will interact with the system through the internet. For example, the student phone and the lecturer computer, through the internet, they will interact with the server. And other systems can interact with the system through internet also. For example, the AIMS will interact with the system through internet, the time tabling system. So we go to the user interface architecture, where the architecture, for example, each route on logging in the landing page will ask you the route among the three, which you are taking. Each route you take, those are the number of the interfaces that you will go through. For example, the student will go through the login interface, the verification interface, fingerprint and image provision interface, respond to attendance interface, download report, and log out. This is the wireframe, how I managed to make my wireframe. For example, the student login page, or they ask the system what you want to do in the system, where after doing it, you log in. After logging in, then you take a picture. After taking picture, you then take attendance. This one is for the major for the lecturer who will take attendance. But if you had a student here on the take attendance, there then would be respond to attendance. Then we go to the storyboard, choosing the role. That is how the interfaces will flow together too. For example, the first page will show you choosing the role. If you choose the student, then you log in. After logging in, you respond to the attendance and then log out. If the lecturer, here there is a missing arrow. If the lecturer logs in, chooses as a lecturer, then he will log in and then take attendance and then log out. Thank you for watching me. Like and share. and subscribe and share the video.